Dear students, in this session we will discuss Whaeatstone Bridge. Whaeatstone Bridge is the most accurate most accurate method that is available for measuring resistance, and the arrangement for measuring the resistance by using Whaeatstone bridge is as shown in this figure. Here, four resistors R1, R2, R3, R4 are connected in a bridge manner, and the node A, node B, across the nodes A and nodes B, we have connected a voltage source of E through a switch SW1, and a current sensitive measuring instrument is going to be connected across the nodes C and D. Here we have used a galvanometer between the node C and D. A galvanometer is a current sensitive microammeter which is going to have zero center scale. At the center there will be zero scale, and whenever there is no current flow through the galvanometer, then the point of the galvanometer will come to rest in vertically upward direction, and when there is a current flow either from C to D or D to C, accordingly the point will deflect either on both sides based upon the amount of current that going to flow. If the current is flowing from C to D or D to C, the direction of current flow will reverse. Okay. Now, whenever the switch SW1 is open, there is no current flow in the bridge circuit. When the switch SW1 is closed, when SW1 is closed, it will causes a current to flow into the circuit, and this current when comes to the node A is going to be diverted into two paths. One is to the resistance R1, another one is to the resistance R2, and let us take the currents as I1 and I2. And when the bridge is under balanced condition, under this balanced condition, there won't be any current flow in the galvanometer. For the current through the galvanometer should be 0. For the current in galvanometer to be 0, the potential at C should be equal to potential at point D. So galvanometer current. For the galvanometer current to be 0, Vc should be equal to Vd. So if the potential, that means the voltage at C and voltage at D are equal, then only there won't be any current flow through the galvanometer. So to get this condition from the diagram, the voltage drop in R1, I1 R1 should be equal to I2 R2. Let it be equation 1. So I1 R1 equal to I2 R2. This is the required condition for the Vc should be equal to Vd, and as there is no current flow, this R1 R3 will be in series, R2 R4 will be in series as there is no current flow in the galvanometer, and this R1 R3 series branch is in parallel with R2 R4 and in parallel with voltage source. Therefore, the current I1 flowing through the R1 or I3 flowing through the R3 both will be equal, and these are given by the total voltage applied E divided by R1 plus R3. Let it be equation 2. And if you see in this branch, the I2 current and I4 current will be equal, and I2 will be equal to I4 will be equal to the total voltage applied divided by R2 plus R4. This is equation 3. So from equation 2 and equation 3, whatever the values that we got as I1 and I2, let's substitute this in equation 1. Then we will get I1 is E by R1 plus R3 into R1 equal to I2 is E by R2 plus R4 into R2. E gets cancelled. If you cross multiply, we are going to get R1 R2 plus R1 R4 equal to R2 R1 plus R2 R3. R2 R1 R2 R1 gets cancelled. So finally we are going to get R1 R4 equal to R2 R3. R2 R4 equal to R1 R3. That is the equation that we got in the previous slide. Now from this equation, R4 is equal to R1 R3 by R2. This is the balance condition. This is the condition for bridge balance. Whenever the bridge is balanced, then R4 is given by R1 R3 by R2. So this bridge is used for measurement of unknown resistance. So whatever the resistance of the element that we need to find out, generally that is going to be connected in place of R4. Let us take the resistance of the element that we need to find out as Rx. Then in place of R4 we are going to connect the Rx, and from the remaining R1 R2 R3, one of the resistance is going to be made as variable. Suppose if I made R3 as variable, then in place of R4 I am going to connect the Rx, and then I am going to vary the R3 such that there is no current flow through the galvanometer. Whenever the current to the galvanometer becomes 0, at that condition the Rx is given by R1 R3 by R2. As R1 is fixed, R2 is fixed, already we know the values, and R3 value is going to be measured whenever R3 value we are going to take. As they are fixed R1 R2, we are going to have fixed values, but R3 is variable one. So we have to take the R3 value whenever the galvanometer current is 0. So at that instant, what is the value of R3? That value we have to use here, and from this relation we will get the unknown resistance Rx. This is the way for determination of unknown resistance through Whaeatstone bridge. Thank you.